nitrogen, this one is going to vaporize a whole bunch and very violently. Okay, let me clean this.
It's gonna work.
Now we're gonna,
Tell us when you're gonna drop it.
Oh, that's cold.
and my mag light is still good, okay? My mag light is still
Functional.
working. What stopped working were the batteries, okay? The batteries froze so that the electrons could not move through. But the mag light did not suffer, even though I had it for a long time. And that's why I'm gonna put these back together and they're gonna work. Okay. Now, the metal is boiling away the nitrogen.
Just gonna shatter.
No, we don't shatter that. It's really, really big and solid, like a big chunk of aluminum, so it does not shatter. But I want you to observe something. Okay, I want you to observe something. All the time that it's going to boil, I want you to see how it will boil. It's boiling in a very steady way. Okay.
What about cloth? Your material.
Cloth, the same as paper. Nothing happens. Now, at the last moment, something really strange happens. There is a big burst of whoa energy, and after that, it's quiet. And for the longest time, I could not explain why. And then Eric Albert, Professor Albert, told me, you know, all that time that you see it boiling like that, the nitrogen is not even touching the aluminum. It's boiling off so fast. When it loses all the energy at the last moment, then the nitrogen wets the aluminum, transfers the energy very fast, and you're going to see it because it's going to boil off incredibly fast at the last moment. Watch this. I'm gonna replenish it. Okay? And watch what happens. In a few seconds, you're gonna see a big whoa burst of energy. Okay? And if you think that there's a lot of fog on the table right now, a lot more. Check it out. It's gonna happen in a couple of seconds. And you can hear it happening.
So it gives up all its heat then?
At the last moment, when the last it's releasing heat. At the last moment, when it has no more heat to release, the nitrogen all of a sudden wets and touches the aluminum, takes a big bunch of heat suddenly, and it stops. Okay. So guys, come close and take a look. You have to stand up and take a look. Gonna happen now, anytime. If anything, you have to be patient. You have to observe.
That's hard.
You've seen it boiling steady for a good long time. There, it's happening. Watch it. You see that? And after that, quiet. Nothing. Watch it. You see? That was the last burst of energy. After that, quiet. Okay?
Now you know the moon is at minus 200.
I'm not using the ice cold water from there, just tap water. Okay? And now, that aluminum being at 200 degrees below zero is going to freeze the water instantly. Okay? Now, I wouldn't touch it because that's dangerous. Okay? But this is what's going to happen.
Holy mackerel.
Freezes instantly. Okay? And here goes again.
You get thicker and thicker layers.
Like candle. Now, another one. Watch it.
Just keeps getting thicker and thicker.
Yep. And every time I dip it, I hear this crinkly sound, which honestly I don't understand. And if it sounds like that, it's still freezing. So that was another layer. Okay, and I'm going to put another one. Okay, so now it's freezing. Now, it freezes so fast that that ice has no shape. Okay? It's amorphous ice. And it's also really, really cold and dry. You don't feel there's no wetness to it, okay? And I want you to feel it, okay? Don't be afraid. I wouldn't let you touch metal, because metal would be dangerous, okay? And it would freeze your skin. But that ice is soft, smooth.
Yeah, it feels like it's like a ceramic.
Bounce again, it's still freezing. Watch it. So that's still freezing water, okay? So that core of aluminum is still sucking the heat through that ice. And ice is a pretty good insulator, okay? The Eskimos know that, and they build these igloos out of ice chunks, and the ice chunks keep the Eskimo pretty nice and warm inside, okay?
So the ice doesn't feel wet because you can't liquefy it?
No, you cannot liquefy it. I mean, it is so cold, it's so well below zero, that it has to go up to zero before it starts to feel wet, okay? You take ice from the freezer, and for the first few seconds, it is nice and dry. And then it starts to absorb heat from the environment, and it, creates a layer of wetness. Yeah, it will break, which is what I'm gonna do. Okay, you getting that? All right. And it breaks, okay? That's still really, really cold. I wouldn't touch it. But, and I made the mistake once of just sitting it on the glass like that, and it froze to the bottom. You see that?
Like that.
Okay?
Like that.
In seconds, it froze to the bottom.
Whoops.
There. All right. Now that ice, by now, it's getting heat from the environment. It's going to bring up the temperature, and it's going to start to melt. It has to get to zero.